Okay, let's unpack this. We're putting on our safety glasses and diving into a world where monitoring pressure is literally a matter of life or death.
It really is.
Our focus today is the NTI E-ISZB Intrinsically Safe Pressure Sensor Transmitter. It's a critical piece of tech engineered to solve a pretty fundamental industrial challenge.
And that challenge is, it's simple but also terrifying. How do you measure processes inside a highly flammable, explosive environment without the measuring device itself becoming the thing that ignites it all?
Yeah.
So our mission here is to really extract the essential knowledge around this device.
A shortcut to understanding safety in these hazardous locations. So what stands out immediately to me is that term intrinsically safe. When you see the source material pricing this transmitter at $810, you know you're paying for something specialized. So what does that actually mean, intrinsically safe?
It's a complete design philosophy. This sensor is specifically engineered for use in what are called hazardous areas, Class 1, Division 1.
And what does that mean in plain English?
Think of a refinery or a chemical plant where ignitable concentrations of gases or vapors. Well, they aren't just a potential accident. They are routinely present under normal operating conditions.
So the highest risk category you can imagine.
Exactly.
That sounds like walking a tightrope. The consequence of a tiny electrical spark is just catastrophic.
Precisely. Intrinsic safety means the equipment is designed so that even if it fails, if it breaks or shorts out, it cannot release enough electrical or thermal energy to ignite those gases.
Okay, so safety is built into its very nature.
It is. And the listing emphasizes that the sensor must operate with a barrier. That is the crucial concept here.
So that high risk demands extreme safety, but it also suggests commercial confidence. I mean, the source material highlights that with details like it being TAA compliant.
Yeah, that's a big one for government contracts.
And it includes a strong 2-year NTI warranty. They're even offering a free trial.
And that barrier is the brains of the operation. To maintain that intrinsic safety rating in a Class 1 Division 1 location, the EISZB sensor explicitly requires an intrinsically safe barrier.
So it's not a standalone device.
Not at all. It's not just the sensor head that's safe, it's the entire circuit. And it's all meticulously controlled by this barrier.
That makes sense. The whole system has to be one integrated unit. So what about human error? Could someone just use the wrong power source? The sources get really specific on power units.
They do, and for good reason. It matters because the barrier protects the hazardous side, but the power supply controls the energy coming into the barrier.
Ah, I see.
The sensor is powered by specific supply units like the E2D or 5D, but it also critically requires a dedicated current regulator module, the ES420 MA24V, to operate.
So what does that module do exactly?
It's not just about voltage. This module ensures the current is precisely limited to milliwatt levels. It guarantees that even if the sensor head is, physically smashed in the hazardous zone, there will never be enough energy released to create a spark.
So it's safety through energy starvation.
That's a perfect way to put it.
And this is where the physical details really connect to the stakes, right? The connection point is built from 316 stainless steel with BMPT threading.
Which means it has superior corrosion resistance and a high-integrity, high-pressure seal. Durability is absolutely non-negotiable in these places.
Of course.
And when you're dealing with constantly explosive zones, separation is protection. For the people, I mean.
Right. And that's where the cable length comes in. The spec allows for a maximum run of 1,000 feet, or about 305 meters.
Which is vital. It lets the monitoring equipment and the technicians be located well outside that hazardous Division 1 area. It's all about maximizing human safety.
So, for the takeaway then, the core principle we've uncovered is that intrinsic safety is about designing failure out of the equation from the very start.
It is. The equipment is engineered to be incapable of generating the energy needed for an explosion, no matter what goes wrong with the circuit.
It's the ultimate redundancy, but built into the initial design. And that leads us to a final provocative thought for you, the learner. The NTI E-ISZB we've been discussing is listed at about $810. However, the sources also list related intrinsically safe models, specifically the EPST series, at a much, much higher price of $2,600.
That's a significant jump.
It is, and it raises an important question. What differences in performance, maybe extremely high pressure ranges or specific chemical compatibility or hyper-accurate measurement? What justifies that nearly triple price jump for components that share the same foundational intrinsically safe rating? Something for you to mull over or maybe explore on your own.